Thank you for having me here.
First question, are you an iOS developer?
Yeah, definitely. I've been doing iOS applications for approximately 9 or 10 years now.
Wow. Nice. How can we help you?
Actually, I have a couple of questions. So recently I've been interviewing for various companies, and one of the questions that I failed to answer thoroughly in one of the interviews was a concurrency related question. So after the interview, I wrote a small simulator, just very basically to see how my solution performs in reality. And the thing is to understand what is being missed from my solution and how was it supposed to answer such question.
Okay, so can you just walk us through the challenge? I have the code here.
So there is a system. We have a system in which some events are generated and they need to be flushed. We already have the flush events method implemented for us, but it's an old legacy deprecated method, and it's written in an inefficient way. We do not have the source code, so we cannot modify it. The way the flush event works is that it receives a list of events as the argument and flushes them. The method is executed in constant time, so regardless of the number of events to flush, it takes 5 seconds for the method to get executed. And because it's like an old legacy method, it's implemented in a way that if it is called before its previous call gets executed completely, it would crash. And it also would crash if you pass more than 50 events to it. So the question is, how should we call the flush events method, and how can we set up a concurrent environment for calling the flush events that would be, of course, not crashing, and also optimized in terms of the time that it takes, because every single time it takes like 5 seconds to get executed.
Right. So the idea is there is this flush events method that you don't have control over. It's right?
Yeah.
And if you call it, it takes 5 seconds to finish. Always, it's constant.
Yeah.
But if you call it before these 5 seconds, before it finishes, if you call it again, it crashes. So you cannot call it again.
Yeah.
If you call it, you need to wait at least 5 seconds to call it again.
Yeah.
And if you call it with more than 50 events, it crashes. So how did you solve it in the interview?
So I came up with an isolation queue so that I can push the call to the calling the flush events method in a serial method, in a serial way, so that it would get executed one by one. Like if I call it, I dispatch the call to the flush events method several times, all of those calls get dispatched to a serial queue, and I make sure that the serial queue blocks the second call before the previous one gets finished. And then I try to make the event buffer that stores the events that need to be flushed in a queue, so that I can make it thread safe. The access of modification to the event buffer would be thread safe. And this is actually a follow-up question, so I explained the other one before this.
Right. So what is the enemy of concurrency?
Yeah.
Mutable state, right? Shared state.
In terms of, yeah, definitely.
Right. So
shared resources, actually.
Yep.
Shared resources in general, right?
Stuff changing, exactly.
Yeah. So like objects in general, they are enemies of concurrency because you need to protect, like you need to serialize mutation, right? So yes, you can use an isolation queue to solve this problem. So it's a serial queue, as you said, right? Correct?
Yeah.
Yeah, so you need a serial
queue. The implementation, I just realized that the implementation queue misses the, yeah.
So it's concurrent. That's the first problem here. Because if you have a concurrent queue and you are accessing it without a barrier, it will crash if two different threads try to mutate the state at the same time. Right?
Yeah.
But you can have a concurrent queue, but every time you're going to access it, you can set a barrier, right? And I think that's what you did here.
Here I used barrier dispatching for making the buffer items access to the event buffers thread safe, I guess.
Okay. So this is the method they call flush events, right? Okay. Yeah, so if you have mutable state, right, shared state, you need to synchronize access to this mutable state to make it thread safe. You should never access it, read or write, without having it controlled within a queue or some kind of lock, right?
Yeah.
And atomic and non-atomic is not enough. You actually need a queue, as you did here. But this queue, if it's concurrent, you need to be careful because you may have issues as well. Because if you're trying to access mutable state with a concurrent queue, two threads may access it at the same time, and it's going to crash, right? If they try to mutate the state at the same time. But if I use a concurrent queue, you need to set up barrier every time you're going to mutate the state.
Yeah.
You can read it concurrently. Reading is fine. The problem is mutating. Every time there's a mutation, you need to set a barrier. Right? Okay. That's the first thing. You also need to be careful in Objective-C because mutable arrays, they are different than Swift arrays. Because you get a pointer, it's a class. So you get a pointer to it. If you pass it around, you might also have concurrency issues. So where are you using this mutable array? How do you add events to it?
Actually, since it's just a simple simulator and it's not being used widely in a system, I'm sure that this is the only place that, this is the only class that works with the buffer, with this array. And the question that I originally explained was regardless of the language you use. Like, imagine that you have an array that holds a list of events and all the things that I explained earlier. So I just used Objective-C here because I'm faster coding in Objective-C, and I didn't even conform to many clean principles, just wanted to see how it works. So I understand the difference between value type and reference types, and definitely that's one thing to consider.
Absolutely. So I want to see how are you mutating this event. For example, here, it's being mutated without a queue, right? So this is mutable state that this is not going to be thread safe, right? Because you may be removing an object when someone is also mutating at the same time.
Actually, this is inside the flush events method, and I just we in the original questions we have this event, a flush events method, and we have no control over its implementation. And maybe I have missed some points in terms of concurrency and being thread safe, and doing that inside this method, because it's actually the area I'm focusing on is on where the flush events is being called. So imagine that you can like even close the flush events, and since it's a black box, we don't know how it works, and
Yeah, but it's important to know that, for example, here that it's mutating some shared state that this class holds, right?
Yeah.
But yeah, okay. So let's say this is what we're saying is this method is not thread safe, right? Let's look at it as a black box.
Right. Yeah. Look at it as a black box. Definitely.
Yeah, and then we know that it's not thread safe, so we need to control access to this method. Okay. And you call it here, and you are controlling the access with the barrier. Okay, async barrier.
Yeah.
Okay, so here it's fine. Now add item to buffer. Okay. You are also adding it with a barrier. Okay, using the isolation queue.
Yeah, I use barrier dispatching wherever I wanted to modify, and I used like the queue normally whenever I wanted to access and read the data.
Okay. And here where you get all the buffer items.
112. Yeah.
So this self.event buffer, this event buffer here is the shared state, and you get a reference to it.
Yeah.
Right?
Yeah.
But then you return the reference. So this is not thread safe because you might be modifying it in a concurrent queue when someone is trying to read it because you return it here. It would be nice here to return a copy of this buffer.
Yeah.
Right? So yeah, here would be ideally you should return a copy. You should have copied it.
But this problem wouldn't exist if I have used like this implementation of simulator in Swift, probably, because that's
Swift. Yeah. Say that again, please. Sorry, I didn't get that with a Swift simulator.
So, I mean, the problem that Caio mentioned is definitely valid, but it wouldn't happen if I was using Swift, because I've been using.
Oh, right. Yeah.
Here, and that would be value types there. So yeah.
Yeah, exactly.
Yeah, if it was in Swift, the array is a value type. So when you assign, you get a copy. Fantastic.
Okay.
And then we get the buffer count. Here's fine. It's a primitive, right? So you get a copy here. Okay, add event. One of the things in the interview question was that there's a limit for the buffer size, right? Which is 50, right? If there's more than 50,
it would crash.
It will crash. But does it say that you should discard? You should discard elements if it's more than 50? Because here you're discarding them, right?
No, this is because of the efficiency in terms of the time that is required to execute the method. So if I call the method with 1 event as the argument or 50 events as the argument, it would take the same constant time. So unless it has reached the buffer limit, I'm not calling the flush event. Like the buffer gets filled with various events, and once it reaches 50, I call the flush events method.
Okay, so you only call it when you reach the limit.
Yeah.
So you add the item, and if it's 50, then you call it. But the problem here is that maybe this is happening so fast. Like the events are coming like every second that it reaches 50 and it calls this method, and then in the next like 50 events come in the next second.
Yeah.
And you're gonna call these flush items again before the 5 seconds, and it's gonna crash, right?
Yeah, and this flush items from buffer is a self-implemented method by me, not the flush events that we have already implemented in the system in a legacy way. So here I use the dispatch barrier.
Right, but you're not controlling that it waits the 5 seconds, the 5 seconds before he calls his method again, right? You know what I mean?
Yeah.
You have to control here, have some kind of maybe another state controlling, like when is it time to call this method again.
Okay.
Because there was this 5 seconds rule that if you call this method before it finishes, and you know it's 5 seconds, so you can only call this method, you need to batch the work in 50 items plus the 5 seconds as well. If you reach 50 items in the buffer, but it hasn't passed 5 seconds yet, it should not call flush events. It should wait until it completes these 5 seconds to be able to call again. Otherwise, it's going to crash. Make sense?
Yeah, but I was assuming that if you call the method as a barrier task, it wouldn't get executed before the previous one is finished. So imagine that 2 seconds has passed from that 5 second, and you dispatch this as a barrier task, and it would get executed unless until after that extra 3 seconds is passed, and then we have already another task ready in the queue to get executed.
Well, assuming that the flush event will block until it completes, right? But maybe the flush event is asynchronous. It returns immediately, and it's up to you to control the 5 seconds. I think that was the question they were maybe trying to make this challenge like harder, you know?
Yeah, I see.
But you never know, that's the problem. You need to ask these questions to the interviewer saying, oh, do you mean that does this flush event returns immediately and does the work asynchronously? So it's up to me as a client to wait 5 seconds, or does it block? Because if it blocks the client for 5 seconds, then it's fine. Then the barrier will do the work. Because the barrier will be blocked for 5 seconds, right? And then it would work. The problem is that if it's asynchronous and it returns immediately, and it's up to you to wait 5 seconds.
I see.
So maybe that's what they wanted.
Yeah, maybe. Unfortunately, I don't have access to them too, as I probably would think of that the next time I face this. But let's assume that the flush events method is blocking, like it actually takes 5 seconds to finish and return. So you are basically saying that this barrier dispatching would be enough to make sure that happens?
Yes, because when you create a barrier in the dispatch queue, even if it's concurrent, right? It's a concurrent queue, and there's a bunch of things happening at the same time. When you set a barrier, it's almost like everything gets on hold, and this barrier, until this barrier finishes, no other task will run in that concurrent queue. And if this task takes 5 seconds, it's going to lock the concurrent queue for 5 seconds. And this is not very efficient because you don't want to lock concurrent queues because you lock a bunch of other work as well, right?
Yeah.
You don't want to lock concurrent queues. It's very inefficient. It would probably be better to have a serial queue.
Yeah. I in the actual interview, I used the concurrent queue for making the event buffer thread safe, and I used another isolation queue, a serial queue, only for the purpose of calling the flush events method. I tried to patch these two into one queue here, as I was calling it with a dispatch barrier method. So yeah, those two need to be separated.
Yeah. So that's it. If this is sync, the barrier would do the work, but I don't know how efficient that would be. Depends how many times you're calling and locking this queue.
I see.
Because there's a cost, for locking, burying the isolation queue. And what else here? What else we need to look at? And someone in the chat is saying the 5 seconds is from NS thread sleep in this case, so it's serial. Yeah, but don't look at this event. What we're saying is that this is a black box. Imagine you don't have access to this implementation, so you don't know.
Yeah, I was just trying to simulate the situation that was described in the interview.
Yes. Yeah, that makes sense. Yeah, but if it's up to you to to handle if these flush events is async and it's up to you to control, then you would have to only call this method every 5 seconds. And not just, you shouldn't have scheduled it and running every 5 seconds, but once you hit 50 in the queue, and you are within allowance after the last time you call the method.
Yeah, both conditions need to be satisfied beforehand.
Yeah, and that's the challenge. That's very challenging, right? With object-oriented programming here, with this mutable state. This is the perfect case for reactive Cocoa, Combine, RX Swift, because it's much easier to manage these state transitions and having these rules like, skip until you have 50 or skip until 5 seconds, It's like one operator and boom, you get it done.
Okay. Thank you. I think I got it there.
Awesome. Anything else?
In the same question, I will merge this with my next question. In the previous implementation, I used the isolation queue and those barrier tasks and the reading task inside that queue to make the event buffer thread safe. Maybe this implementation is fine if that's the flush event method acts serially, but this event buffer itself is not thread safe. So as a follow-up question, I was asked to make the event buffer thread safe, and this is a follow-up question in the interview. And my next question was, generally, how should I design classes in a thread-safe manner? In general, like how should I deal with that? We can merge these two questions together, maybe talk about the second one and use this as a sample case or whatever. I want to know how to approach when I want to design a class in a thread-safe way.
Yeah, to design thread-safe classes, you need to control access to mutable state. Every time you're going to mutate state, access state, it needs to be within some kind of queue or have some kind of lock that will prevent more than one client, more than one thread doing the operation simultaneously, right, concurrently. Because the enemy of concurrency is mutable state. So the more you can avoid mutable state, the more thread safe your code will be, the less you're going to have to protect against problems. That's why Swift brings value types, because it makes it much easier to manage mutation and threading. It doesn't solve all the problems. You still need to manage the state, but the idea is to eliminate mutable state as much as possible and operate with pure functions where you pass the data, immutable data, it will transform the data in something else and return new data. Instead of mutating existing state, you create new states and you operate on them. And then it's thread safe. But if you're mutating shared state, mutating a pointer, then you may have issues and you're going to have to synchronize access. And then you have performance penalties, right, for synchronizing access as well.
But since we do not have the synchronization method, like the asynchronized methodology in Swift, what is used instead in Swift, like using semaphores or what's
dispatch queues?
Yeah, I think anything.
Dispatch queues are probably the simplest way to do it, like you did here. In Swift, you even have the more Swifty APIs with the classes, dispatch queue, and so on with nicer APIs.
Yeah.
And the idea is to control access. If you have a concurrent queue, as we said, if you're using a concurrent dispatch queue, when you're accessing or mutating a state, you need to do it with a barrier, right? If it's a serial queue, every mutation needs to be within that queue as well, but then you don't need barriers because they are serial. Every operation will be executed.
Okay.
serially. Just like with core data, every time you access, you're going to transform any state within a managed context, you need to do it within the .perform block that will guarantee that every change is within the managed context queue.
Yeah.
It's the same idea. You're going to protect access to mutable state with a queue or with a lock. But the simplest way is to use a queue. We have a mentoring session 13 about it, but I don't think it's public.
Yeah.
But we have video. We have a video. Search on YouTube how to test code that uses dispatch queue, because it's not just about testing, but also how to structure your code not to decouple threading from the classes and deal with threading in the composition root, which simplifies as well threading, because the threading is contained in one single module rather than having a bunch of classes that they all manage their own state and need to be thread safe. So you avoid duplication as well. So YouTube, how to test code that uses dispatch queue, something like that.
I will definitely search the channel, or search among the videos in the channel, so I probably find it.
Awesome.
And okay, my last question is regarding system design interviews, and I've been going through various system design interviews, and I wanted to see how you would approach answering a simple sample question revolving around that question. And here's the question. Imagine that you want to implement a page with a table view on it, very basic. The content of the table view is being fetched from an API, and in each cell you have a text and an image, but you definitely are not receiving the image data. You receive a link to the image, and you need to fetch that image separately. How do you design that page, and how do you wire modules together in that page?
So how do you answer this question?
Yeah, how do you approach it? Like,
right. So I'm asking, how would you reply to this question?
So I came up with like a semi-clean architecture approach. My view controller, my views would start loading, and then the business logic, the interactor for that page would use a networking. I mean, I'm assuming we have a networking module that fetches the response from the API. My interactor, which is responsible for handling the business logic, would talk to that networking module and fetch the response. It would pass it to the presenter, prepare it for the view, and the view controller would present it in the end. And when each of those cells are being displayed, this is I saw that as a UI level generated event. So the UI level would pass it to the presenter that this cell is being presented, and if the image is not loaded for that, the presenter passes this UI level generated event to the interactor, and interactor would talk to the networking API and fetch the image and pass it downwards. And each of these layers are protected by boundary level boundary protocols, so that you don't depend on concrete classes and all those principles that are like the core of clean design. So that's basically the way I approached it. And then you need to address how you need to talk to the download image service you have, because that event is being generated like various times. If user is scrolling fast, and you may receive several fetch image number X, like several times, and you need to prevent multiple calls for actually fetching that. So,
and how would you prevent the
concurrency
issues with this?
I was thinking of a request pool that would the request would be added to that pool and get executed. And whenever you want to add a request to that pool, you check if the request is already in the pool, and if multiple requests are coming for a single image, you need to cancel the requests that are being duplicated, and that's pretty much it.
Okay, and how would you cancel that? For example, cell goes off screen, and to preserve the internet connection and data plans, you would want to cancel that request, right?
Yeah.
How would you cancel it?
It depends on how you configure the download image service. Like if you want to execute like download one image at a time, you probably are downloading one image, and the second image that is waiting to get downloaded is going off the screen. So you can wrap all of these requests in operation blocks, and you can cancel that operation, and you can configure the operation queue to execute like certain amounts of operations at the same time. You can use operation queues and operations to cancel.
But who would own the operation queue in this design? That you said you have interactors, you have presenters. Who would hold the operation queue? The interactor. And the view would also hold a reference to its own operation, so you can cancel it. How would that work?
I honestly didn't think about that, but then you might, if user scrolls back and forth over like 3 or 4 images that can fit in the screen, but also can go off the screen, the view, you will end up with the view adding and removing from the operation pool like really fast. If you scroll like 70 pixels upwards and then downwards and do this repetitively, the UI will do this before anything else. I mean, that pretty much occupies most of the time, and it also would be like some sort of waste, because if the image gets downloaded and it's off the screen, it would be cached, and then the next time that user would scroll to that area and wants to see that image, you can load it instantly. So the thing that you want to prevent is duplicate requests for duplicate downloads, and preserve bandwidth and the traffic in that area, not fetching an image that is currently off the screen but can be on the screen in like 5 seconds.
Yeah, and there are APIs for that, right? There are the prefetching APIs you can use. That's going to tell you when to cancel, when to start loading, like hot loading the next images. But like the architecture in general seems like you're following more like a Viper template, right? You have the views, the interactors, the presenter.
Actually, it was more of a Ribs architecture that Uber recently open sourced, but yeah, they are similar in various terms, both Viper and Ribs.
Right. It's just if you say that to a company that they don't like these architectures, for example, right? I try to avoid like saying like specific names. I would say something like, I like to separate the user interface from network requests. For example, I don't want my views making network requests or managing the network state, right? Because then my UI is much simpler.
Or I would isolate. Yes, exactly.
Say isolated, right? So I would like my UI just to send events like, oh, load this image, or this cell is visible now, or
it's not.
Events, but not responsible for managing the requests, for making the requests. And you can say
the way I approach it so that the interactor would do that. You may use a repository pattern, and even the interactor is agnostic regarding where the image is being loaded. If it's downloaded in a database or in the memory, or it's being fetched over a network or whatever, and the UI should be agnostic of how the business logic is going to deal with the image. It just needs to have the data for that image and load it.
Yeah, so now you explain it much better, because you explain that the UI is agnostic of these operations, right? That maybe even the interactor is agnostic of network frameworks, like maybe using some Alamo Fire behind the scenes, but it doesn't have to know about that, right?
Yeah, definitely.
Yeah, this is what's important to say in the interviews as well. Explain the main ideas, right? Decoupling the UI from network requests and isolating business logic in another layer as well. So the UI doesn't have business logic or networking code or database code even, right? So explaining that this is the design you would like to have, like separating concerns pretty much, right? Following good design principles.
Yeah. Or you mentioned the presenter there. You don't have to be specific about the presenter as a component, like you can have a formatting / presentation layer in between, that binds whatever needs to, or formats any data the UI needs, right?
Yeah, transformation layers, right? Like mapping layers.
Yeah.
Because you get data from the network, and then you need to transform it into UI image at some point, right?
Mm-hmm.
So you can present it on the screen, and you say like there's levels of transformations. You have a request, and this request is transformed into like a network request, and this network request will return data, and this data needs to be transformed into something else, like UI image. Or you also, as part of this, you might, as you said, you might cache this data, so you don't have to load it again when you scroll the table view. Where would you cache it? In which layer? In the UI? In the presenter? In the where would the cache be?
Actually, assuming that the interactor is using a repository pattern to fetch the data, it probably will be cached on the interface that is between the repository and like it's an insider policy of the repository that you're using. Either cache this, or maybe wants to fetch it again over the network or whatever. So even the interactor should be agnostic about how that is being handled.
Right. So the repository,
it's a loader that needs to cache the.
Yeah, that's right. The repository is responsible for doing the caching, because like caching for performance reasons is like an infrastructure detail, right? You're just preventing more requests. It's not business logic, right? It's like an optimization. Optimization you usually do in the infrastructure layer at the boundaries, right? For example, like URL session already has URL cache that will cache some responses, and you can increase the cache size in memory or in disk as well. And this can be done in the infrastructure layer, unless you have business rules around this caching. Like you can only cache it for a certain amount of time, we can only cache if it's a specific user, is a premium user, or, if there's some business rule, then you would put this business logic maybe somewhere else, in the interactor in your case. Yeah. Right, not in the repository. The repository would only deal with infrastructure details. So it's important to say that as well, when you're dealing with caching, like if there's any business rule, then I will put it in X component. Otherwise, if it's just an infrastructure optimization, I would do it in the infrastructure layer, which is the implementation of the repository, right?
Yeah.
Makes sense?
Yeah, makes sense.
So it's important to explain really well, because sometimes like we get used to a pattern like ribs, viper, or whatever, and we start saying words like interactor and presenter, and we expect the other person to also know exactly what we know. Yes. And you need to understand that maybe they don't. Right? They don't use the same nomenclature. Like, it's not that they don't understand separation of concerns. It's just that they use they're used to other names, other patterns. If you come saying like interactor, you say presenter, and they're like, no, we use MVVM here, or something like that.
Exactly. Or they call them services,
Yeah, or they call it services. Yeah, instead of calling interactors, some people call them services, some people call them model controllers. There are different names for like similar concepts.
So if I want to make sure that I understood you correctly, you're saying that the general approach I had with the question and the system design was kind of correct, but it's more about the communication and the way I should present it, right?
Yes, explaining it well. Yes. Because there's a lot of things going on. Like, it's a simple thing to say like, oh, it's a table view that you scroll and there's some images. We say, oh yeah, some people would reply like this, oh, just use Kingfisher because it deals with all the caching, it deals with all this thing, right? Which is a library. But that's not what the interviewer wants. When they ask it, they want to know if you can build it, if there was no libraries. Maybe they're going to use the library in the workplace, but they want to know if you know how to structure your layers in a way that you're not going to have concurrencies as you scroll, concurrency issues, that you're not going to load more data than is necessary, and so on. So you need to understand the points they're looking for, even in a simple exercise, like optimizations. Because you mentioned optimizations, you mentioned that it's important like to avoid concurrency issues as you scroll and also not load more data than you want, but you didn't explain how you would solve those problems with the design, right?
I see, yeah.
And if you explain that better, you have much better chance of passing the interview. The important points, the important points which they're looking for is like these concurrency issues, the caching, the optimizations in the infrastructure, and also separating the layers so the UI is not making network requests, and that you also have a place for business logic if needed, and you're following like some good patterns, like you say, the repository that deals with the infrastructure, and so on.
I see.
Make sense?
Yeah, definitely.
All right. So I think that's it for today.
Awesome.
Yeah. Thank
you so much, Amir.
Thank you for your time and your support.
Awesome. Thank you for joining us. All right.
Have a great
Take care.
Bye. Take care.
Bye.